Welcome everyone. So we got 25 minutes to go through stream processing. When I start put these slides, I thought that's like let's just approach it from 5 challenges, what you can learn from it, and at some point like it became 6, 7, 8. So I decided just to remove it and just focus on the stream processing and challenges in general. So my name is Fawaz Ghali. I lead DevRel at a company called Hazelcast. Anyone heard of Hazelcast before? Cool. That makes it easier for us to discuss what we want to achieve today from stream processing. So anyone can recognize these guys on the screen today? Come on. It's easy. Who are these? Beatles, yes. So I'm based in Liverpool, and when I mention stream processing, people assume we're talking about, I don't know, music or TV streaming and so on. And this is right, yeah? It's part of the stream processing story, but it's much bigger than that. So it's much bigger than, events or music streaming or TV streaming and so on. And the idea of stream processing is to be able to actually see how big the market is. So for example, if we want just to discuss, let's just say fraud detection. So I assume most of us here have one or more credit or debit cards. So if you try to get some money out of your card, or if you try to do some kind of online payments, there is a mechanism just to detect if there is a fraud or not, right? And this is big industry, right? So we're talking about about 40 billion per year or 400 billion per 10 years. So this is just part of the stream processing for fraud detection. Obviously, you see it in, I don't know, maybe in IoT, or you see it in machine learning, or even you see it in other SREs and websites. And basically what we wanted is just to see what you can achieve for your application and essentially which areas you have to focus on, right? So if I'm talking to your boss, most bosses assume that if there is a use case or a problem, they assume you go straight from this problem or this solution to results or some kind of output, right? And we all know that's not the case. It's usually a roller coaster. So you go through various aspects when it comes to, I don't know, deploying your application, monitor this application and see what kind of alerts, when it's gonna fail, and what you can do to predict and avoid it, right? So it doesn't matter what you're working on here. Maybe you're working on some kind of machine learning or AI, maybe microservices, or even some kind of applications. It's always, even if you have perfect application, there is always a risk for this application to fail when you get it into production, right? And this is exactly what we want to focus on today, what you can achieve, how you can do it, or basically, we're not talking about development at this point, we're talking about production, right? And there are so many areas that you can focus on. So deployment, for example, one area, and it has its own challenges, how you can serve your application, another area, and also how you can monitor it, right? So we're talking about monitoring performance, for example, or monitoring usage, for example, CPU, memory, and so on, or even trying to analyze your logs in real time. So all these aspects comes into a one area, which is the stream processing, right? And because it's a CRE events here, so probably some of you are working on one or more aspects. You see it on the screen here. Of course, with any cloud provider, you probably have touched it, or similar tool or similar framework. And essentially, stream processing touch every one aspect on this screen here. So for example, if you work with S3 data, you're gonna do with stream processing. If you have some kind of VPC or some kind of database, whether it's rational or non-rational, if you have a Lambda function, and so on. And obviously, because we're talking about monitoring and alerts, usually it's kind of the CloudWatch or what is equivalent, right? So this is where you want to make sure you're able to track and trace all messages, and what you can do to say, hey, I want to scale this application, or even if you have auto scaling on multiple AZs, for example, at some point you need to make a manual decision, and this manual decision usually comes from the application behavior. It's nothing to do with the data, nothing to do with the application itself, just sometimes you have to do it, and I'll explain some use cases for this. And for this talk today, what we're going to cover is two areas. So we're going to cover just monitoring and alerts. Can anyone tell me how many events or transactions you handle per time frame? What's the largest number? Hundreds. Okay. Any larger than this number? Millions, billions. Here you go. So if we're talking about 1 billion, right? So let's just say we have 1 billion. How easy it is just to, pinpoint exact log message that can break your application or need some kind of manual input or human interactions here. So we're talking about billion events, and we want just to make sure we have set of events or smaller set where it's easier to predict what's going to happen in next step or next event or next time frame and so on. And anyone can guess how long it takes for an eye to blink? Okay, 25 milliseconds here. 100. Come again? Yeah, it's probably slower. So on average, right, it takes around 1/3 of second, so 350 milliseconds. It depends how old, it depends where you're from, and so on, genetics, and so on. So let's just say 1/3 of second. And same thing for clap hands, for example, it's slower, definitely. Or if you have some kind of digital SLR, these kind of events are in sub-milliseconds we're talking about. And you see it everywhere. So it doesn't matter what application or what use case you use, whether it's a fintech, for example, banks, whether it's IoT or smart devices. Hospitals, for example, they use stream processing in real time, obviously with the sports and VAR, for example, or machine learning and AI. So we're talking about pretty fast events, right? So it's hard even for normal applications to manage. So if I ask you now to go on right application to measure eye blinks in this room, you probably can get away with it. It's easy, it's not hard. But if I ask you to scale it, and maybe you go outside in the town center and measure it for everyone, it becomes really challenging. It's not easy, even like if you have budget to deploy it on some kind of cloud solution, and even if it's unlimited budget, you still have to make a decision based on specific actions, because this is where latency is your friend, right? We want to minimize latency as much as possible. And sometimes it's easy, sometimes it's not. If we're talking about hardware, network hoops, and so on, it is not in your hands. There's no way. Of course, you can deploy it locally or in same region or same AZ, but usually it is much harder than that. So we're talking about how you can configure your application, or how can you develop application where it becomes easier to minimize latency. So latency is the key word here. So let's just take this example here. It doesn't matter if it is fraud detection or not, but it's easier to explain. So we have some data. We want to ingest this data into our application. We want to do some kind of enrichment. So we want to add more into it. We want to do some kind of data transformation on top of it. And then you can do some kind of prediction, for example. And then you can do act. So essentially, every time you swipe your card or do online payments, this request goes to your bank, right? Your bank checks your, your credit score, whatever else, and then it gives you back the answer whether to validate or invalidate this transaction, right? So what's the SLA for this type of events here? Anyone can guess? 2 seconds. Yeah. So we have 2 seconds. It's much faster than 2 seconds. It's much faster than 1 second, actually. So again, depends on the banks, what type of infrastructure they have, and whether they use some kind of open banking or not, and so on. So we're talking about 50 milliseconds, right? So what took me like maybe 3 minutes or so to explain, usually banks have SLA of 50 milliseconds, which means they need to respond to your request in this time frame or in this SLA. Obviously, there are some data here. I'm not going to explain it because it's going to take some time. So you can take screenshot, but essentially it's just JSON format. What card number, where are you based, for example, what is your age, how is your credit score, for example, and so on, what type of machine learning they want to deploy to detect fraud or not, and whether they want to do some kind of data transformation in order to get this response. So this 50 millisecond, most of this time, apart from this process, is out of scope. There is no way for you to basically make it faster or minimize latency on it. What you can do is how you configure your application, right? How can you write your code, or how can you deploy it if you are solution architects, or even if you, for example, do some kind of monitoring for applications. So this is what you can do, and I've seen some use cases where it goes from minutes to seconds, or from seconds to sub-seconds. So I was just discussing this concept with someone who was really happy with their gaming. So they had gaming app on their, on mobiles. And then basically they spent around maybe 2 seconds to load this game into your, to log in and start playing. And they were quite happy with it. So when I mentioned, hey, have you thought of, speeding it up? And he said, what you're talking about, 2 seconds is it's not big deal. It's 2 seconds, nothing. So I'm not going to mention names because this this talk is being recorded, but some companies have done some research here for this, how long it takes for a end user like you and me to switch between apps. And the answer is in sub-milliseconds, right? So it takes less than 1 second if one app is not responsive to do the switch. So this is physically, it's not possible to grasp, but take my word for it, and you can go online and check it. So if it takes a sub-millisecond to explain or to give answers or switch between apps, you can see how important it is in order to minimize latency. So in simple terms, high performance, we're talking about millions or billions of events, obviously. You need to act on 2 different types of data. This is very important. You can't get away with one part. Most of us here deal with the batch data or historical data, and we're talking today about real-time data, right? But in order to get the best out of both worlds, you need to combine between 2 different types of data. So first is the new data. So this is real-time, and you want to process it before you store it into the database. And second part is the historical data. So this is data stored in file system or some kind of database. I'm not going to spend so much time on this. So if you're from machine learning or AI, or if you're interested, come grab me afterwards. Essentially, features are either in real time or in batch data, or combination between 2. It depends. For example, now if I ask you to describe this mic, for example, whether it has limited or unlimited features. So some of you will say, hey, Fawaz, this has limited feature, obviously. So weight, for example, echo level or echo range, and so on. And that's right. But if you want to take it into production, the features which are limited becomes unlimited. And this unlimited feature means it's not possible to predict or handle in real time. So come grab me afterwards if you're interested in this explanation here. Again, I mentioned alerts and trends. So we want to pick up exact messages that we have interest in. All right, I will show you some examples here today. And to do stream processing with Hazelcast, what you can do is connect your data source. So data source could be a message bus, for example, Kafka, Apache Pulsar, Red Panda, and so on. You can connect it to IoT device, for example. You can connect it to a cloud tool or cloud framework, and so on. and you combine multiple data sources in order to actually process the data before you store it into a database. This is very important. Let me repeat it again. You want to process data before you store it into a database because we're trying to minimize latency, right? And of course, at any moment, you need to provide context. So if I try now, for example, to take some money out of my card outside, when I swipe my card, okay, bank checks my card number, PIN code, and so on, but they also do some kind of checks from database or file system. For example, I don't know, where was last time I used my card? So if I use it in Liverpool and maybe half hour later I use it in London, it should be detected as fraud, right? So there is no way to commute from Liverpool to London in half an hour. So that's batch data. That's why you need context, and then you can send it out to wherever you want. So Hazelcast, if you're not familiar with this platform, so it's open source. You can try it out. So this example today, I'm gonna show you what you need to do. You don't need to be Java expert or Python or even SQL experts. You can write some commands here. And the platform allows you to do exactly what we're trying to do here for stream processing. So it takes the responsibility of stream processing through the Jet engine and the fast data store, which is the kind of in-memory product or part of the platform here. You can connect it to different clients, obviously. You can connect it to multiple sources, and same thing, you can actually send your data once you process it to some kind of WebSockets, for example, or file system, and so on. So it's pretty much easy to get going with Hazelcast, and it depends where you're sitting, right? So for example, if you're sitting inside your application, you can use embedded deployment. If you're sitting in client server mode, you use client server mode. If you're using Kubernetes or Docker, or if you're using any cloud provider, you can actually connect it or use some kind of cloud solution provided by Hazelcast. So the cool thing about it, every time I mention, and this is very important, doesn't matter if you're using Hazelcast or not, how do you scale, right? What does scaling mean? So if I ask you now what scaling means to you, some of you will say, I want to scale my data, for example, and some might say, hey, I want to scale my process, right? And the answer is basically a combination between the two. You always need to think about how you can scale data and at the same time how you can scale performance or compute, right? And in order to do this, it's very important to store your data as close as possible to your process. If you're using microservices, for example, and you have multiple regions and you have multiple microservices deployed, you want your data to be stored as close as possible to the microservice attached to it. So this becomes easier, obviously, and faster because we're trying to minimize latency. Who heard of Kafka here, or who uses Kafka? Cool. So demo today is about Kafka. I'm gonna show you what you can do with Kafka. Kafka is a message bus, which means you can move data from A to B. But we want to do more with your data, right? We want to be able to process this data, and you can use some kind of Python. Again, it's machine learning part of it, so that's where most solutions are currently being deployed in. You don't have to, obviously, if you're using Java versus Python, you might have some preference. Again, grab me afterwards. I can explain why you need to deploy it in Java, but you have your machine learning in Python, and why it is best way to basically enhance performance. Of course, you need some kind of DAG format. DAG format for microservices means you'd split your code into multiple parts, and then you run it on different regions or different clusters and so on. And this becomes easier to communicate between different microservices. And if you use Kafka alongside this, you can take your data from one topic, feed it into different microservices, and then get the output after you process it and feed it to a different microservice and so on. So it's pretty cool when you see it. And obviously you need to have some kind of virtual machine to run it, right? So it depends on your cluster and your nodes, your operating systems, and so on. You eventually end up some kind of virtual machine, but also you need to make sure you're aware how you can configure your virtual machine with any stream processing solution. So again, it doesn't matter if you're using Hazelcast or not. Virtual machines, when you try to connect multiple applications with multiple data sources, it becomes really messy. So you need to think about how you combine results in every single step into something called composite output or composite score, because most of us are stuck in the upper side of this screen where you have or collect data, you do some kind of analysis, and then you actually have some kind of decision making. And here we're saying no, it's not the right way to do it. What you need to do is basically combine multiple microservices or multiple apps or whatever you want to call it in order to reach something called, you might be familiar with this term, blue-green model. So the blue-green means basically you send some kind of application or microservice or whatever you want to call it to end user, and there is exact model running in the background, and you do switch between the two so it doesn't affect end users. And if you want to change your code without taking this application down, you should be able to do so. So this example today is online, so you're gonna need some kind of guideline. We have 25 minutes, so I'm not gonna spend so much time on it. So scan this code if you're interested. Let's just talk pizza, right? Do we have pizza for lunch today? Do you know? You don't. Okay, so let's talk pizza here today because it's easier. If you try to place an order online, right? Sometimes you get these recommendations. So again, it doesn't matter if you're, ordering pizza or whatever. So if you order margarita, for example, what type of starters or desserts are attached to it? And essentially, all this process, you get all these recommendations in real time. So it's not stored in database, it's not stored in file system. What you get out of it is like a real-time recommendation. And here what we have is Red Panda, for example. You take this Red Panda data from one topic, pizza orders, you ingest it into a Hazelcast, and then you do some data enrichment, and then you send it back to wherever you want. So it's pretty nice and it's pretty easy. So I'm gonna show you how it works here quickly before we move to the questions. So I have a Red Panda cluster running locally here. It doesn't matter where you want to run it. I can't use this mic, so I'm gonna stop here or maybe leave it here so you can hear what I'm talking about. So I have Red Panda running, so message bus or Kafka or anything. And then what I'm gonna do, I'm gonna generate some orders here. So I'm using Python for it. And the Python code is just essentially just generates random data, right? So you see these orders here. Let me increase size so you can see. So we have timestamp attached. Again, you can use it in your application as alerts. You have pizza type, for example. You have user ID, where this, and then you have quantity. At the same time, I have Hazelcast running locally as well. So if I try to query same data, you can see here. Let me grab this command quickly. So I just want to see this process here. So this topic. So if I run it now, you see exactly the same thing. So on left, you see Red Panda data, and on the right side, you see it inside Hazelcast, right? So it's the same details, nothing has changed here. Of course, you can do some kind of alerts or scene processing on it. And if, say, for example, you want to recommend specific starter or specific desserts, or you want to enrich your data, what you can do is combine between multiple topics or multiple streams. So this command here on the screen, again, I'm gonna increase it so you can see what it does. I'm joining two topics. In my case, they are now inside Hazelcast in something called IMAP structure, which is key value pairs. And if I just want to recommend a specific starter, so for example, in this case, it's just, as extra 2, could be anything. And you just need to run it in SQL. Obviously, you can run it in the way you want. And now this is the order. So if I run it again, it's working, right? And this data is not coming from database or file system. It's running in real time. And if I want to enrich it in real time, so I'm gonna copy this comment here, and suddenly you start to see some kind of white character. So suddenly you just start to see specific recommendations for this users, right? So if you look at second column, you can always see this specific, that you can specify what value you want to recommend and so on. So it's pretty nice and pretty quick. You can try it yourself. It doesn't have to be pizza or, you know, online shopping or fraud detection. You can use the same concepts on your log messages, for example. Or if you try to do some kind of monitoring, you can do so. Obviously, it depends how big your cluster is and how many nodes in your cluster. There are always a configuration file to configure best use case or best outcome for your use case. And with that being said, I'm just gonna finish off with this slide here. So if you're interested in, you know, stream processing in real time, this is community Slack. Feel free to join this community, ask questions, contribute to GitHub, open source. So, you know, do whatever you want to do with open source. So that being said, thanks very much. Hopefully it was useful. Come grab me. I'm staying afterwards as well if you have a question, or we can now take some questions, right? Thank you.
Yes, are there any questions to the...
Hi. First of all, thank you for the presentation. It was great. One of the biggest challenges when working with Kafka and streaming services is reliability because of some limitations of infrastructure. Like, for example, if data gets stored too much time in Kafka, it might get retained. So how do you... Can you explain a little bit more, maybe as a use case, how do you increase the reliability? Because might be that the pipeline that processes the data might have a bug or something. How do you increase the reliability on those kinds of streams so you don't lose data?
Sure. So hopefully everyone got the question is about reliability. I'm not gonna answer it for Kafka, right? So
Yeah, in general.
So there is someone else can cover this Kafka. So I can answer it from Hazelcast perspective, right? So essentially, every time you have a cluster, you have node in it, or multiple nodes, right? So essentially, say, let's just keep it simple here. One cluster, 3 nodes, right? So what you want is not to have master-worker relationship. So you want basically to have co-worker relationship, which means every time you add nodes into your cluster, our other nodes know about it, and vice versa, right? And every time you do processing on top of it, you need basically to save state. So in simple terms, in plain English, you need to have a mechanism to say what was your last event you processed or ingested. Obviously, you need to save it. So in first instance, it has to go into memory because, you know, we're trying to minimize latency, but at some point you need to save it into hard drive or hard disk. And that's where you can actually increase the reliability, if that makes sense.
Yeah. Okay. Thank you.
Good. Question?
Maybe last question.
Hello, I was just curious about, I didn't know Hazelcast before. So you say that there's no database behind that, but you have like a fully support for SQL language. So how does it work? Do you write disk? Do you have like RocksDB or something behind?
Sure. So this question about SQL, and we're talking about SQL, but there's no database into it. So it's two-part answer here. So everything you see now on screen is in memory, right?
Okay.
So that's very important, very crucial to understand because we're trying to minimize latency, right? At some point, you want to save your data. So saving data means you need some kind of database or file system, in order to save this data. Hazelcast can write into hard drive, so can write to any database you want, or you can use some kind of and some kind of Hazelcast features where can save. It's called tiered storage, which means first you save it into memory and then you save it to hard drive. So that means basically you save the state of your data after it's being processed.
So here you have like a key value pairs in memory,
Sure.
distributed on several machines.
That's
And-
correct.
Okay, that's cool.
You don't need to use SQL. You can use any programming language with it. So that makes it easier. Depends on, which programming language you prefer. So there's a Java because it's built on Java virtual machine, Python, C++, or even you can write your own commands. So you can write a Docker compose in order to have a specific configuration for your specific use case.